Hey there, geometry boys and girls. Today we're looking at 9-3 rotations. You spin me around, baby, around. I'm sorry. Okay. What a rotation is. So you take a center of rotation. Okay. And you move it a certain degree measure. And now both, after you rotate, it's the same distance from the center as your original point. So if I take this V and I go up angle X, then my V prime is the same distance away from R as V. I went up this X, which is my angle of rotation. This is an isometry because these will be congruent. Okay? Anything too scary? Let's take a look at one. Let's say we want to rotate a lob of 100 degrees about C. Now guys, positive degree is counterclockwise. Negative degree is clockwise. Okay? So here's how you do it. I make OC. And then I'm going to go 100 degrees. And then I'm going to make this guy. I'll call this be my O prime. Okay? Now I take this, connect my L to C. I go 100 degrees. This has to be about the same distance. I'm going to call this L prime. And this right here is going to be 100 degrees. Then I'm going to do it one more time. Connect my B to my C. I go over about 100 degrees. That's good enough. And that's my B prime. Connect the dots. Ba boom, bada bing. Ain't no thing but rotation. Okay? These two things are congruent. These two lines are going to be congruent. And these two lines are going to be congruent. Okay? Let's go. Okay. So the center of a regular polygon, so you have some regular polygon. It's actually not too bad. The center is equidistant from all of the vertices. Okay? So all these are the same length. That's good to keep in mind because technically each corner, each vertice is a rotation of the next. Because I can rotate around and spin it and stop it and you won't know where was where. It makes sense? I don't know, maybe it does. Okay, identifying a rotation image. Point X is the center of regular polygon penta. What is the image given a point or segment of the given rotation? So what is the image of E under a rotation of 144 degrees? Well, this whole thing is 360, right? So what's each triangle going to be? What's 360 divided by 1, 2, 3, 4, 5 of those? According to my calculations, they are 72 degrees. So it means each one of these spaces is 72 degrees. So if we're starting at E, remember I'm going counterclockwise. So this would be 72 degrees, and this would be my 144. So A is my image. Okay? Same thing with this car tire. This point in the middle is CQMX. What's the angle that maps M to Q? Okay, and there's actually two answers. So I'm going to kind of make this triangle, or the triangles. So to find out what the space is between each of these, I go 360 divided by 3, which is 120 degrees. Each gap is 120 degrees. Okay? So how do I get from M to Q? Well, if I go this direction, that's negative 120, right? Because that's clockwise. Clockwise negative. If I go this direction, I had to go 120 plus 120, which is positive 240. So both are correct. Okay. So let's think about this. If a 50-degree rotation puts A to B, how do I go from point B to A? Well, A to B was 50 degrees. So how do I get back to A? Well, 360 minus 50, which is 310 degrees. Okay? One more.
Well, find the coordinates of the image of the point A.
Let's take 2, 3 for a composition of two 90-degree rotations about the origin. Okay, remember what the origin is? 0, 0. Okay, we're starting with negative 2, 3. And I'm rotating it 90 degrees about the origin twice. So I'm going to the origin, and I have to go 90 degrees out. Now think, if I had to go up 3, this time I'm going down 3. I'm still going over 2, so that's my A prime. Okay, because that's 90 degrees. Now I have to rotate this point 90 more degrees. A double prime. So I'm going down 3 over 2. So my point would be 2, negative 3. Okay. Again, because I went 90, I'm going to go 90, you go down 1, 2, 3 over 2. That means I'm going to go down 3 over 2 this way. Do the same thing for the last one. Okay, guys, that's all I got. Enjoy.